So, good afternoon, guys. So, I think this topic is left. So, first of all, we will cover this topic controlling VTY access. What do you mean by controlling VTY access? Let me explain this thing to you first, then we will come on the. Now, this is my router. Fine. Just think like it is connected to another router, and here I have a LAN. This is one more router. This is one more switch. This thing is clear. Now, this router is having how many IPs? 1, 2, 3. Let's say 1, 2, 3. If you want to remotely access this router through telnet or through SSH, you can use any of the IP 1, 2 or 3. Yes or no? Yes. Now, here I have users X, Y, Z, P, Q, R. These are my users. Now guys, what you can do is you can control access of VTY lines. You can. What do you mean by this particular thing? That I can control that which user will get a VTY line and which user will not get. So what I will do on R2, I will configure a standard ACL. All of you know standard ACL is a source based. What we configure in or what we specify in standard ACL? Source. So like this I am writing here permit P, permit Z, permit Y. After that deny any. If I don't write deny any, it will be by default deny any. This is a standard ACL, yes or no? Now I will call this standard ACL in my VTY lines. Line VTY 0 to 4. How many VTY lines I have created? 5. I will write here access class ACL number. Let's say ACL number is 10. Direction will be in. मुझे जितना याद आ रहा है मैंने डिस्कस किया था, क्योंकि मैंने आपको बताया था यहाँ पे इन और आउट का मतलब, मेरे को जितना याद आ रहा है मैंने क्लास में डिस्कस किया था, क्योंकि मुझे जितना याद है मेरे से किसी ने पूछा था सर ये इन और आउट का मतलब क्या होता है यहाँ पे. इन मीन्स हाउ मेनी यूजर्स कैन telnet this particular router. Now when you have telnet, how many users can go out from here? Go out from here. This thing is clear? So direction will be in. What do you mean by this thing? That whenever a user will come to the router and user will say, I want a line. Which line? VTY line. It means he is accessing the router through SSH or through telnet. He want a line. This time router will check the ACL. If the user is permitted in the ACL, only then a line is given to the user. If user is not permitted in the ACL, line is never provided to the user. It means what we are doing? We are controlling access of which lines? Of VTY lines. This thing is clear? अब आपका पैराग्राफ पढ़ लेते हैं. Now we will read his problem. Should I read?
सर इसमें एक्सेस लिस्ट बनाने के बाद इंटरफेस के ऊपर एक्सेस ग्रुप के अंदर एंट्री करने की जरूरत
नहीं. Where I am calling my access list? In the line VTY mode. Fine? Okay. Read this paragraph. I am reading. Don't give up. There always a. यार शुरू से ही पढ़ते हैं, ऐसे क्या समझ में आएगा? Trying to stop users from. यार आप पढ़ो, मैं नहीं पढ़ रहा. पढ़ो ना सारे मिलके. Now, first of all, he is telling you the reason why he is not putting the ACL or why he is not configuring the ACL on the interface. First of all, try to understand this thing. He is not doing so because if I have to telnet this router I can telnet using this interface also, this also, and it means I have to configure ACL on 3 interfaces. Instead of configuring ACL on 3 interfaces, he is providing you the solution. He is providing you the. That's why we are configuring your ACL on line mode. This thing is clear? Now, next line. पढ़ लिया पहला पैराग्राफ? कोई इशू किसी को? कोई बात ना समझ में आई हो? See, what do you mean by latency here? Try to understand. If this is a router, you are configuring ACL in which direction? Yes or no? Every traffic which will pass through this interface will be checked, which will cause a latency, and your network performance will be dragged down. Will be dragged down. Drag का मतलब होता है खींचना. परफॉर्मेंस नेटवर्क की क्या होगी? ड्रैग डाउन. फाइन. और उससे क्या कॉज होगी? दैट विल कॉज लेटेंसी. ये कहना चाहता है यहाँ पे.
ये वाला मीनिंग खराब है, इसे एक्सप्लेन कर दीजिए. समझ में नहीं आता कंप्यूटिंग के टर्म्स में क्या कहना चाहते हैं लेटेंसी को.
Time it takes for a specific block of data on a data track to rotate around.
बड़ा कंफ्यूजिंग सा.
नहीं, he is not explaining latency here. He is explaining rotational latency. हाँ जी. latency का मतलब होता है टाइम. वैसे यार डिले होता है वो टाइम. डिस्टर्बेंस. लेटेंसी का मतलब मेरे हिसाब से तो why is saying latency here, because every traffic which is passed through the interface will be checked, and that thing will cause latency in a big network. जो मुझे समझ में आ रहा है. Fine, you can read it again. दोबारा पढ़ लो क्या लिखा हुआ. Really won't scale well if you happen to have dozen, even 100 of interfaces. Now would it? And think of the latency dragging down your network as a result of each and every router checking every packet just in case the packet was trying to access the VTY lines. Horrible. Packet you are sending. Packet is a transit packet. Router will check that packet also. This thing is clear? Now, don't give up. There always is a solution, and in this case a much better one, which employs a standard IP access switch to control the access to the lines themselves. Fine. Next thing, why does this work so well? Because when you apply ACL to the VTY, you don't need to specify the protocol, since access to the VTY already implies terminal access via telnet, or because router already knows that VTY lines are used to provide access to which protocols? Telnet and SSH. You also don't need to specify a destination address, because it really doesn't matter which interface address the user needs as a target for the. All you really need to control of is where the user is coming from and which is betrayed by their source IP. ठीक है जी. You need to do these two things to make this happen. Create a standard ACL and apply this using access class command. You can do it, it's practical on your own. There will be no issues. Fine. कोई problem इसमें? And always keep one thing in mind, that whenever you are using this particular thing, or if I talk about real time, in real time on router you will always configure SSH. You will now never configure telnet. So
No need to access this.
we need access list every time.
Even in SSH.
Yes, even in SSH also, because it is controlling the access of VTY lines. It is not about username and password. It is about who is permitted and who is denied.
जैसे
हाँ जी।
हमें पिन को ब्लॉक करना है तो उस कंडीशन में क्या करें?
ICMP.
ICMP यूज करता है और ICMP इको उसको यूज करता है.
ICMP echo is for echo request. ICMP echo reply is for echo reply.
तो सिर्फ ICMP को ब्लॉक करना होगा.
ICMP echo. If you are blocking, if you are trying to block the request, if you are trying to block the reply, then it will be echo reply. Echo means echo request. Fine. This is our chapter of WAN. Fine. So first topic, defining WAN terms. Read these all terms at your place. We don't have much time here. Fine. There is no need to read these terms. Fine. WAN connection time. Leave these terms. If you want to read, you can read lease lines, because circuit switching, packet switching are not used nowadays. Fine. Here you can read about frame relay, you can read about ISDN if you want to, otherwise leave it. You can read about HDLC, PPP, PPPoE. You can leave all other things, no issues. You can read about MPLS if you want to read. Fine. Leave this topic, cable and DSL. Fine. Leave this topic, digital subscriber line, what it is. ADSL, leave this topic. There is no need to read. Leave PPPoE, we will discuss it in CCNP. LRE, leave it. Cabling, the serial transmission. Leave all this stuff. DT, DC. Leave all this stuff. There is no need to read. Now, start with HDLs. You have to start this chapter from leave all other stuff. Fine. If you will read that stuff, that will just fuck your brain. Some neurons will die. Yes. Fine. So, पढ़ना शुरू करें? कौन पढ़ेगा? आपसे स्टार्ट हो जाओ, एक एक पैरा पढ़ना, अपने नंबर से पढ़ते जाना, बैठ के आराम से.
High-level data link control protocol. The high-level data link control protocol is a popular access
मजाक नहीं करेंगे अब. Yes.
The protocol is a popular ISO standard bit-oriented data link layer protocol. It specifies an encapsulation method for data on synchronous serial data links using frame, characters, and checksums. SDLC is the point-to-point protocol used on these lines. No authentication is provided by SDLCs.
What is trying to say? First of all, let me explain the stuff. What is trying to say that HDLCs, first of all, a layer 2 encapsulation by default present on serial lines. Any issues? Any problem? Now he is saying that it will provide you on this particular link. See, first of all, what is frame synchronization? Yes? छोड़ो उस बात को. Frame synchronization means if I am sending 10 frames from here, 10 are received here. Fine. And what do you mean by FCS? That in between there is no change in my data. All of you know the meaning of FCS? Frame check sequence. That whenever from a serial end a router is sending some data, it will calculate FCS. On the same data, other router will also calculate FCS. If it will match, only then it will accept. And the last line is saying that HDLC cannot provide authentication on this particular link. Why we need authentication? First question is this. Okay guys, for some time, take example. Fine. Like you have a company. You have to take connection from ISP. If I go 5 to 7 years back, if you want a WAN service, what kind of cable you were using for WAN service? You were using serial cables. It means ISP will provide you a serial cable at your end. Yes or no? Just think like, I am ISP, I am providing you a serial cable, I am providing him also a serial cable. Now after 1 month, I am saying your bill is 30,000. You have access internet or you have access 100 GB of internet and your bill is 30,000. He is saying, I have not run internet. I have not accessed even Google for a single time. Why should I pay the bill? Just try to understand what was going on. That I have provided him a serial cable. In between, what he has done. जैसे टांका नहीं लगा लेते तार में. He has connected his wire and he has connected the same serial cable to his router. Now actually, who is connected? Sagar. Who is using the internet? Sagar. Now there is a problem. That how I will get to know that the customer is valid or not? It means if I will use a serial link and I will use HDLC as encapsulation, I will never get to know customer is authenticated or not. It means HDLC will never support authentication. This thing is clear? कभी भी HDLC पता नहीं लगा सकता कि सामने वाला एंड ऑथेंटिकेटेड है या नहीं. जैसे आपने फोन का कनेक्शन लिया है, किसका? फोन का. आपकी तार घर पे आ रही थी, मैंने बीच में से तार ब्रेक करके अपने घर पे तार लगा ली. कर सकता हूं मैं ऐसा? अब जितनी कॉल्स मैं करूंगा बिल कौन भरेगा? आप भरोगे? लोग ऐसा करते थे. पीपल वर डूइंग द सेम थिंग. लाइक मेरी कॉलोनी में तो मैंने ऐसे किया हुआ है. मैंने क्या किया, मेरे नीचे वालों के घर पे ब्रॉडबैंड कनेक्शन लगा हुआ है. देखो वो 10 बजे सो जाते थे, उसके बाद ब्रॉडबैंड का यूज करता था. उन्होंने गलती कह दी. लाइक मैं पहले सिविल हॉस्पिटल, मेरे मम्मा जॉब करते हैं तो मैं वहां रहता था. मेरा घर ऊपर था, उनका घर नीचे था. तो मेरी विंडो से ही बाहर अंदर आती थी मेरी. वो मैंने बिल नहीं भरा, मेरे पापा ने बिल नहीं भरा. क्यों नहीं भरा? आपको पता है मैं क्या करता था. भरा गया घर पे, अरे गेम खेलता था, कुछ ऐसा गलत नहीं करता था. फाइन, मैं गेम खेलता था, उनका स्ट्राइक सारा दिन बैठ के पढ़ता नहीं था बिल्कुल भी. तो पापा ने इंटरनेट का बिल नहीं भरा. तो मैंने क्या किया, वो डब्बी लगी हुई थी. फिर वाला बॉक्स, वन वायर वाज कमिंग टू माय हाउस, वन वायर वाज गोइंग इन देयर हाउस. मेरा कनेक्शन तो क्या था पता हुआ. मैंने उसकी वायर में क्या किया, पंखा लगाया, जोड़ी, अपना इंटरनेट सारी रात मैं मत चलाता था और सुबह डब्बे में वो वायर वापस उनकी लगा देता। तो ये एक तरह की क्या थी, चोरी। लेकिन इसमें मेरे को एक शरारत और करनी पड़ी। मैं उस भाई के घर गया, मैं उसका यूजर नेम और पासवर्ड भी देख के आया, वरना मैं इंटरनेट कभी भी, because nowadays when you are using internet, actually first of all you have to authenticate yourself to the ISP that you are the correct customer who is taking the access. This thing is क्यों उनके बच्चे छोटे छोटे थे, मैं थोड़ा बड़ा था उम्र में, ठीक है जी। So this is the thing, मेरे को आपको ऑथेंटिकेशन का मतलब समझाना था, आपको समझ में आ गया that how ISP will check that you are authenticated user or not. It means by default HDLC will never provide you authentication. Next thing, yes, बारी आपकी।
In byte-oriented protocols, control information is encoded using entire bytes. On the other hand, bit-oriented protocols use single bits to represent the control information. Some common bit-oriented protocols are SDLC and HDLC, TCP and IP are byte-oriented protocols.
Now, what are bit-oriented protocol and what are byte-oriented protocols? Read this paragraph once again. Yes. Read this paragraph once again. तभी समझ में आएगा, पढ़ो।
In byte-oriented protocols, control information is encoded using entire bytes. On the other hand, bit-oriented protocols use single bits to represent the control information. Some common bit-oriented protocols are SDLC and HDLC. TCP and IP are byte-oriented protocols.
Okay. Guys, what is the difference between bit and byte? 1 byte is equal to whenever TCP and UDP traffic will travel, or whenever traffic will travel, or whenever these protocols are used, information is binded in bytes, control information. Fine. But if I talk about HDLC, control information is present in form of bits, never in form of bytes. This is what he is trying to say. Next paragraph.
कंट्रोल इंफॉर्मेशन
बात करेंगे, 2 मिनट रुक जाओ, हेडर आएगा भी HDLC का आगे आएगा। Yes.
HDLC is the default encapsulation used by Cisco routers over synchronous serial links.
Now, when he is saying over synchronous serial links, what do you mean by synchronous? Guys, all of you remember one thing, that whenever we define or we connect routers through a serial link,
Please have a seat. Please have a seat.
okay, fine, पढ़ो भाई, किसकी बारी थी?
And Cisco's HDLC is proprietary.
Bro, we were discussing this thing. Cisco HDLC is a default encapsulation by Cisco routers over synchronous serial links. Second line.
And Cisco's HDLC is proprietary, meaning it won't communicate with any other vendor's HDLC implementation.
It means now one thing is clear. Cisco is having a different HDLC and other vendors, if they are using HDLC, is different. In the line, he is trying to say Cisco HDLC is different and others vendor HDLC is different. How it is different, after some time you will get to know. Fine. Now, I want to explain the meaning of, what do you mean by synchronization? Synchronous means they are synchronized, yes or no? What do you mean by synchronized? We need to define a clock rate. Without clock rate, serial link will never get synchronized. And nowadays, the serial interfaces you are using have by default a clock rate of 2 lakhs. Have by default a clock rate of 2 lakhs. So that link will automatically get synchronized. यार
What parameter?
मेरे को नहीं पता, आपकी बुक में नहीं दिए हुए वो पैरामीटर, और वो पैरामीटर पता भी नहीं होने चाहिए. What I am trying to say, if at one end, let's say you are DT, I am DC. All of you know that serial cable have 2 ends. One is DT, one is DC. DT means data terminal, DC means data communication. You always assign clock rate at DC end. Fine. Now I am a DC end. If clock rate is not defined, then I will send you a HDLC frame. I will never mark or I will never send clock rate in it. Yes or no? It means the link will never come up. Protocol will remain because link will never be synchronized. Link will be synchronized with the help of clock rate. Next line, next paragraph.
But don't give Cisco grief for it. Everyone's SDLC implementation is proprietary.
What is trying to say? Everyone HDLC implementation is proprietary. It means if I am having a Juniper router and if I am having a Cisco router, I cannot run HDLC encapsulation between them. Why? Because Juniper is using its own HDLC, Cisco is using its own HDLC. This thing is clear? Next thing.
The reason every vendor has a proprietary SDLC encapsulation method is that each vendor has a different way for the SDLC protocol to encapsulate multiple network layer protocols.
Next slide.
If the vendors didn't have a way for SDLC to communicate the different layer free protocols, then SDLC would be able to operate in only a single layer 3 protocol environment. This proprietary header is placed in the data field of the SDLC encapsulation.
What is trying to say? Is trying to say, like all of you know about Ethernet header. In Ethernet header we have a type field. What is the useful type field? What protocol we are using at layer 3? Yes or no? Or above layer 2? Which protocol we are using? This is the use of type field. Now what is saying that every HDLC header has a different, or you can say variation in type field. Have variations in. Now there can be a chance that Juniper HDLC header is just supporting IP. It's just supporting IP at layer 3, but Cisco's HDLC header is supporting IP also, IPv6 also. Agree or not? So there will be variation in the type field. So there can be a chance that HDLC is supporting multiple layer 3 protocols, and there can be a chance HDLC is supporting only one single layer 3 protocol. That's why it is never compatible. That's why it is never. Now, next thing. Now, it is Cisco HDLC. In Cisco HDLC, what we have? Read this line. It means if between two Cisco routers. What is saying? I was saying if I am having two routers, fine, and both routers are Cisco routers, which encapsulation I will be running between them by default? They will support multiple layer 3 protocols, because which field we have? Proprietary field is here working as the type field, as a type field. But in case of normal HDLC, we don't have a proprietary field. It means normal protocols. Or if I have two Juniper routers, they will only support which protocol? IP. They will never support IPv6, because there is no proprietary field in case of Juniper. This thing is clear? तभी मैंने पहले ऐसा कहा था कि जो डिफरेंट वेंडर्स का HDLC है वो कितने लेयर 3 प्रोटोकॉल सपोर्ट करता है? सिर्फ एक. लेकिन सिस्को का कितने सपोर्ट करता है? मल्टीपल. दिस थिंग इज क्लियर? Now read this paragraph fast. भाई कहीं इसने बताया वो वाली बिट के बारे में, इसके बारे में आप पूछ रहे थे इन द बिगिनिंग. आप तो अपना क्वेश्चन भी भूल जाते हो. कंट्रोल बिट्स के बारे में, कंट्रोल इंफॉर्मेशन के बारे में इसने सिर्फ हक दिया है यहाँ. हाँ यार देखो, जब एक ऑथर बुक लिख रहा होता है, ऑथर को दिखाना होता है उसे आता है, तो वो कुछ टर्म्स ऐसे यूज करता है सामने वाले को समझ में नहीं आती। अब मैं क्यों समझाऊं किसी को जब बुक में इंफॉर्मेशन दी नहीं, मैं पहले पढ़ चुका था वैसे, ठीक है। हाँ जी, ये वाला पैराग्राफ पढ़ो जो इंपॉर्टेंट है, फटाफट पढ़ो सब लोग, फटाफट। In this case we will use, okay, who will read about PPP? पढ़ो शुभम फटाफट यार फटाफट।
Point-to-point protocol is a data link layer protocol that can be used over either asynchronous serial dial-up or synchronous serial (ISDN)
media. He is trying to say that it will, you can use it for ISDN connections also and dial-up media also. Now what is ISDN, what is dial-up, leave it, it's not your part to understand, fine. But you must know that it can work on synchronous media also and it can work on asynchronous media also, fine. Next thing, मैं पढ़ता हूँ। It relies on link LCP to build and maintain data link connections. NCP enables multiple network layer protocols to be used on point-to-point connection. Now, PPP works on actually two protocols, NCP and LCP. NCP stands for Network Control Protocol. LCP stands for Link Control Protocol. What is the use of LCP? LCP is used to set up a connection between two devices. And NCP is used to define which layer 3 protocol you are using. Which layer 3 protocol you are, whether it is IP or it is IPv6 or it is any other layer 3 protocol. This thing is clear? Any issues? No. We will discuss that how LCP will establish the connection. Let me discuss this, read this paragraph. Yes, you can read about LCP here. Yes. A method of establishing, configuring, maintaining and the point to point. It also provides features such as authentication. Next thing. See, first of all HDLC. Either I can use HDLC or I can use LCP. See, LCP is just used to maintain the connection or establish the connection. How connection is established, we will discuss that thing. Wait for some time. But after that, what is the use of NCP? Specific to. It means what layer 3 protocol you are going to use is specified by which protocol in PPP? NCP. Network Control Protocol. Okay. A method of establishing and configuring different network layer protocols for transport across the NCP is designed to allow simultaneously use of multiple network layer protocols. Two examples of protocols here are IPCP and we will discuss about IPCP and CDPCP. Wait. Yes. Read this line. PPP session establishment is divided into three phases. First is, second is, third is, now. Yes. Read the first paragraph. Sagar.
LCP packets are sent by each PPP device to configure and attach the link. These packets contain a field called configuration option that allows each device to see the size of the data, compression, and authentication. If no configuration option field is present, then the default configurations will be used.
Next phase.
Authentication phase. If required, either chat or map can be used to authenticate a link. Authentication takes place before the network layer protocol information is read, and it's also possible that link quality determination will also occur simultaneously.
Next thing.
Network layer protocol phase. PPP uses the network control protocol to allow multiple network layer protocols to be encapsulated and sent over a PPP data link. Each network layer protocol establishes service with NCP.
Look here. This is R1, this is R2. Fine. First of all, which phase is there? Connection establishment phase. What will happen? Actually, on this link, first of all, this router will send, or this router will tell R2. What size of data? It means MTU. Fine. First of all, R1 will tell R2 about its interface, MTU. Second thing, compression if used. If R1 is using any compression mechanism, what are compression mechanism? There are some ways that on serial links what you can do, you can compress your data. That thing is not in our syllabus, but what I am trying to tell you, that R1 will ask R2, I am using this compression mechanism, are you using the same? If they are using the same, only then compression thing will be fine, otherwise link will never come up. This thing is clear. Third thing, what authentication you are using? What authentication you are using? Now, R2 will also tell the same things to R1. Fine. This thing is clear. This is the working of LCP, link control protocol. Now, if these three things are fine, a LCP connection is established. What is established? LCP connection. This thing is fine. Now, after that, they will tell each other what network control protocols are allowed. What I am trying to say, these things will be predefined. Predefined like when R1 will send IP traffic to R2, R1 will put the information of IP in which protocol? When R1 will send IPv6 traffic to R2, which protocol? In which protocol it will send the information? In NC. This thing is fine. Now, how authentication takes place between R1 and R2? First of all, between R1 and R2, one will act as PPP server, other will act as PPP client. Now, again I am back on the same example. Just think like I am ISP and these are my customers. Who will authenticate? They will authenticate. To whom? They will authenticate. To me. It means I will act as PPP and they will act as PPP client. They will act as PPP client. This thing is clear. Now, if they are acting as PPP client, they always send me their username and password, and what I will do? I will match those username and password with my database. If they will match, I will provide them access. If it will not match, I will not provide them access. This thing is clear? This thing is fine? So, PPP server configuration is different and PPP client configuration is different. In PPP, two types of authentication are supported. At this time, authentication is negotiated by which protocol? LCP. Two types of authentication are there, PAP and CHAP. We have other types of authentication also, but that are not in your syllabus. Now, what is PAP? What is CHAP? Just learn about it. PAP means password authentication protocol. Whenever R1, like they are clients, whenever they will send me user and name and password, they will send me clear text. So if Sagar is an intruder or Sagar is planning for a man in the middle attack, Sagar can capture username and, but in case of CHAP, what is CHAP? Channel handshake, challenge handshake authentication protocol. In case of CHAP, all things will be encrypted. This thing is clear? So this is the main difference between CHAP and PAP. Either you can set authentication to CHAP or you can set authentication to PAP. This thing is clear? Always keep one thing in mind, that clients or customers always act as PPP client and ISP always act as PPP server. On the server, what thing you have to maintain? Database. And client will always send username and password. This thing is clear? Now you can read this thing from your books, there will be no issue. This example is actually wrong. What is IPCP and what is CDPCP? We have to discuss about these things also. NCP, by default two protocols are used. One is IPCP, stands for Internet Protocol Control Protocol. What is the use or what is the feature provided by this IPCP protocol? That after connection established by LCP, R1 will tell its own interface IP to R2, and R2 will install that IP address in its routing table. In its R2 will tell its own interface IP to R1, and R1 will install that IP address in the routing table. It means if on R1 and R2 you are using IPs of different network, they can ping each other. Let's say on R1 you are using network AIP, on R2 you are using network. By default you cannot ping each other. Yes or no? Yes. This thing is clear without using routing. But in this case, as you run PPP over this link, there will be a protocol called IPCP that will be working. R2 will tell about its IP to A. R1 will install this IP also in its routing table. R2 will also install this IP in its routing table. So if we are using different IPs on both the ends, they will still communicate. There will be no issue. This thing is clear? Any problem? I can disable this feature also, and real time it is mostly disabled. Second thing is CDP-CP. Cisco Discovery Protocol Control Protocol. Now, as connection is established, now R1 will send its CDP information to R2 and R2 will send its CDP information to R1. They will not use normal CDP, they will use CDP. This thing is clear? And भाई क्यों? PPP क्या है एक? Open standard protocol. CDP-CP is used by every other protocol. This thing is clear? Sorry, every other vendor. Let me read this thing. Okay, we will read it from the very beginning. Start. हाँ भाई पढ़ना शुरू करो फटाफट. Time
Frame was one of the most popular web services deployed over the past 2 decades, and there is a good reason for this cost. And it's a rare network design or designer that has the privilege to ignore that all-important cost factor. By default, frame relay is classified as a non-broadcast multi-access NBMA network, meaning it doesn't send any broadcast such as zip updates across the network.
Okay, now you have a first point for frame relay. That frame relay is classified as a non-broadcast network. On this network, by default, broadcasts are not allowed. It means if you are using here R1, R2, they are connected via frame relay, and you are running RIF. R1 will never able to send update to R2. By default, broadcast and multicast is not allowed. What I am trying to say, if this is R1, R1 is connected to R2 and you are running here with service frame relay. On this link, broadcast and multicast will not be broadcast plus multicast, not allowed. Any problem? Yes. Leave this thing. See, here he is defining the reason that why we need frame relay. Okay, I will tell you the reason. यार ये पढ़ना है आपको, आप घर जाके पढ़ लोगे इसको पक्का? ठीक है, मैं आपको फ्रेम रिले समझा रहा हूँ सारा, ध्यान से सुनो. What was happening in the past before frame relay? Fine, we were using dedicated lease lines. What was the problem? Just think like I have a site in Mumbai. Fine. You want to connect it to Delhi. You have to use a lease line. Agree? You want to connect it to, let's say this is Delhi. You want to connect it to Bangalore. You have to use another lease line. You have to connect it to Chennai. You have to use one more. In this case, how many lease line connections you have to take? 3. But in case of frame relay, what you can do? You can take a single connection, and by using that single connection you can reach multiple sites. You can reach how? In this case, bandwidth will remain fixed. Guys, what is the use of lease line? Lease line means I am having my own path. I'm having my own path. Own path is like I have for network bulls I have a lease line of 10 Mbps. It means ISP is saying that you will get 10 Mbps always. You are using it or not. Your 10 Mbps are reserved for you. Your 10 Mbps are reserved for you. This thing is clear? This thing is fine? It means you will always get a speed of never less than 10 Mbps. This thing is clear? Now in this case, if every lease line is of 10 Mbps, R1 will get how much speed? 30 Mbps. He has to pay for how many lease lines? 3, and he has to pay for 30 Mbps. Even though he is not using, he has to pay. This is the main thing of lease line. Like I have a lease line of 10 Mbps, price is fixed. I can use unlimited upload and download, but speed will always remain 10 Mbps. I can upload and download unlimited, but I have to pay for 10 Mbps. Price for 10 Mbps is like 1,60,000 per year for 10 Mbps. Fine. Now, what benefit frame relay has provided me? Just think like this is frame relay. Frame relay is actually a service that you are getting from the service provider. Like you have sites, one in Delhi, one in Bangalore, other one in Chennai, and this is Gurgaon. First of all, this time how many links you need? Only one? Yes or no? Just think like this is 10 Mbps. He has also taken a connection of 10 Mbps. He has also taken a connection of 10 Mbps. He has also taken a connection of 10 Mbps. First thing, frame relay. You can only run frame relay on which links? Which links? Serial links. Now, minimum bandwidth provided by serial links is 1.54 Mbps and maximum bandwidth provided by serial links is 45 Mbps. This thing is clear? The serial links you are having in labs are of 1.54 Mbps, but in real time, if I am using a serial link, bandwidth of that serial link is 45 Mbps. Now, first of all, how many lines I have to take? Only one line. And second benefit, I have to pay for the data that I will upload and download. I will not get something unlimited. This thing is clear? Now, if frame relay is provided me a connection of 10 Mbps, he will not always provide me 10 Mbps. This is the first thing. What he will say, that there is something called CIR. CIR means committed information rate. That I will provide you a minimum speed all the time. Let's say 7 Mbps. All the time I will provide you a 7 Mbps speed, but I cannot guarantee that I will provide you 10 Mbps. But there is a chance. If my service is not used by many users, you can use their bandwidth. It means when network is free, you can use more than 10 Mbps. But I cannot guarantee that I will provide you 10 Mbps every time. मैं तुम्हें हमेशा 10 Mbps दे पाऊंगा, ये पॉसिबल नहीं, लेकिन 7 Mbps की मैं कह देता हूं गारंटी. मैं तुम्हें 10 Mbps से ज्यादा स्पीड भी दे दूंगा अगर मेरे नेटवर्क पर यूजर क्या होंगे, कम होंगे. क्योंकि why he is saying so? Because frame relay is a shared medium. It is working here like a switch. It is working here like a, okay. If I go to the previous case, in this case, how many subnets I have to purchase? Public IPs. 3 subnets. In this case, I can use a single subnet. It means that will save my IPs also. Yes or no? So this particular thing is called point to point, and this particular thing is called point to multi-point. Yes, I am connecting Gurgaon to Delhi, Bangalore, Chennai. Point to multi-point. I am using the same path. If I want to reach Gurgaon, if I want to reach Chennai, if I want to reach Bangalore. This thing is clear? So now let me discuss some more terms related to frame relay. Frame relay is actually a layer 2 encapsulation. You can run it on which links? Serial links. Next thing, FRS means frame relay switch. Frame relay switch is nothing but a router on which routing is disabled and it is acting as a frame relay switch. See, what is going inside this ISP? This is not our concern. We must know what is going between ISP and us or between our sites. This thing is clear? So let's say this is R1 and let's say this is a simple switch. If R1 want to reach R2, what R1 will do? R1 will generate a R. Yes or no? By default, if R1 want to reach R2, R2 knows about destination IP. What R1 will do? R1 will generate R. It means switch will forward information on the basis of MAC address. Yes or no? But on serial links there is no MAC address. So what information I will use at layer 2? I will use DLCI. DLCI stands for data link control identifier. Data link control. Now try to understand the main thing. I am a switch, all of you are users. Or think like I am a switch, all of you are sites. If you want to reach him, what you will do? You know his destination IP. For destination IP, you will generate a ARP. ARP is received by me, I will broadcast. This is the process which is going on when all of you are connected through a switch. Just think like this time I am a frame relay service provider. Now at layer 2, which information you are using? At layer 2, which information are you are using? DLCIs. Which information you are using? DLCI stands for data link control. Now guys, listen to me carefully. In case of ARP, we have to find destination MAC address using destination IP address. But in this case, you must know what is your local DELC to reach the particular destination IP. What is your local DELC? What I am saying, what I am trying to say, let's say this is R1, this is FRS. FRS means switch or frame relay service provider. This is R2. R1 must know, just think like here IP is 10.0.0.1, here IP is 10.0.0.2. R1 must know which DELC. DELC is a number. DELC is just a number which must be greater than 16. Now why it must be greater than 16? It is a predefined thing. You cannot change it. Fine. So let's say I am using a DELC 102. Now R1 must know that it must use DELC 102 to reach R2. Now this thing is creating a path. This thing is creating a path from R1 to R2. This path is called PVC. This path is called permanent virtual circuit. Now what FRS will do? FRS, like switch is building a MAC address table, FRS will build a switching table like interface number 1, interface number 2. Interface number 1, we have a DELC 102. Clear? Interface number 2, we have DELC 201. Switch traffic from 102 to 201. See, whenever 102 will send traffic, this guy will never read by IPs because it is using which layer information? Layer 2. Switch cannot read layer 3 information. In the same way, frame relay switch cannot read layer 3 information. This thing is fine. Now look here. This guy will say information is coming from which DELC? I have to switch it to 201. And by this one thing is very clear that PVC is always unidirectional. PVC is always unidirectional. It means if you want to come back from R2 to R1, you have to define. You have to tell R2 that if you want to reach R1, you have to use the DELC 201. It means for a bidirectional connection, how many DELCs you need? 2. How many DELCs you need? 2. And frame relay switch will forward information on the basis of DELC. This thing is clear? Any doubt, any problem? To anybody?
एक्चुअली R3 भी सपोज उधर होता तो 102 यूज करेगा कि उसके लिए अलग है?
R1 FRS, R2 R3. Now R1 will say I will use DELC 102 to go to, and I will use DELC 103 to go to R3. R2 will say I will use 201 to move to R3 will say I will use 301 to move to R1. How many sites are directly connected? 2, R1 to R2, R1 to R3. How many DELCs you need? 4. This thing is clear? Because one DELC will provide you a unidirectional path. And how this guy will switch information, you want to know? Like this. Switch 1022 201, switch 1032 301. When information is coming from 102, to which interface which it will switch the information? The interface which is associated with 201, yes or no? And if information is arriving from 103, it will switch information on the interface which is assigned to 301.
सर ये एक लिंक पे अलग-अलग डेल से वैल्यू कन्वर्ट
Why? On the same thing I am coming now. That on a single interface, we can assign multiple del C's, but vice versa is not possible. Vice versa is? What do you mean by vice versa? That you cannot assign same del C to multiple interfaces. Why? It will confuse frame relay switch. It will confuse? Yes. How frame relay switch will switch the traffic then? Fine. What I am trying to say?
सर फिर R2 R1 पे 102 102 हो सकता है
हाँ जी?
मतलब R1 पे भी जो डेल्सी 102 है वो R2 पे 102
नहीं हो सकती
लोकली होता है ना वो
यार. लोकली आपको लगता है स्विचिंग किसके बेस पे हो रही है? del C के बेस पे.
सर ये बताना पड़ेगा
del C, you have to purchase del C from whom? From service provider.
मतलब 102 तो मतलब उसके लिए होगा ना कि R1 से R2 जाने के लिए.
भाई फिर वही बात तू कर रहा है. ये R1 है भाई, ये बीच में पापा भी तो है सबके. Fine. R1 knows, let's say here we have IP 10001, here we have IP 10002. Now you are saying he is using 102 and he is also using 102. Let's say he is 10003. According to you, he can also use 102. मैं यही बात कह रहा था ना स्टार्टिंग से, that you cannot use same IP for, same del C for multiple interfaces. You cannot use same del C for multiple interfaces. And I am still saying the same thing. What will be the issue? Just think like this is a router. Router is having how many interfaces? 1, 2, 3. For one interface, first interface, which del C you have defined? For interface number 2? For interface number 3? Now what will be the mapping? You have connected it like this. Connect 1 to 2. It means you have mapped the del C like this. Yes or no? Connect 1 to 3. 1022 again. How it will get to know when a traffic is coming from one, it has to send here or it has to send here. So this is the case that you cannot define same del C to multiple interfaces. This thing is clear. In this case, this guy will be confused.
सर वो पहले वाला एक बार लेके आना
ये लो जी.
सर इसमें R2 और R3 आपस में कर सकते हैं ना
हाँ, we have to define a different del C.
मतलब 201 2 301
नहीं.
उसके लिए भी अलग डेल्सी.
Fine. We can define a different del C. This thing is fine.
सर इधर से जा सकता है R1 से R2.
R3 can reach R2 via R1. R3 can reach R2 via R1.
और सर डायरेक्टली करना हो तो एक नया DLC.
You have to define a new mapping. This thing is clear?
Which protocol is used for DLC mapping?
We are coming on that thing, bro.
सर डायरेक्टली कैसे होगा सर R2 से R3 में DLC मतलब दो अलग लिंक बनाने पड़ेगा. वर्चुअल समथिंग.
PVC, you have to create a different PVC. Like from R2 to R3 you are defining a del C 104, and from R3 to R2 you are defining a del C 40. This thing is clear? Read this paragraph first of all. Do it fast. By default, frame relay encapsulation is of two types. One is Cisco, one is IETF. When you are connecting two Cisco devices together, by default you have to use encapsulation Cisco. But if you are connecting a Cisco device with a non-Cisco device and you are running frame relay between them, you have to run which encapsulation? IETF. That is the thing. That's all. आगे चले, कोई मुश्किल बात तो नहीं है. What is saying, अगर दो Cisco device है, fine, you are running frame relay between them. Which encapsulation is by default used? Cisco encapsulation. Cisco frame relay encapsulation. But he's saying if you are using two different devices, one is Cisco, other is non-Cisco, then which encapsulation you have to run? IETF. Fine. Next thing. Frame relay operates using as opposed to the physical circuit that leased lines use. As opposed, भाई मैं ये physical circuit नहीं use करता. These virtual circuits won't link together the thousands of devices connected to the provider cloud. Frame relay. Read this. बहुत मारूंगा. मजाक पता है आपको, बहुत बार ऐसा नहीं करना होता. मैं चाहता हूँ कोई चीज रहनी नहीं चाहिए. यस, आप जो क्वेश्चन पूछ रहे थे पढ़ो अभी. यस यस, फाइन, फटाफट पढ़ो आगे. आपने क्वेश्चन पूछा था ना, हमें अपनी डलसी का पता कैसे चलता है? विद द हेल्प ऑफ इनवर्स आर. In normal switch scenarios, what thing is working? R. Here, what thing is working? We will discuss how inverse R will work. Wait. First, read this paragraph.
Yes, it is somewhat similar to all the that it maps a dual signal IP address, kind of like ARP address with MAC address to IP address. And even though you can't configure inverse ARP, you can disable it. It runs on a frame relay router and maps the DLCI to an IP address from frame relay, so it knows how to get to the IP address at the other end of the PVC. You can see IP to DLCI mappings with the show frame relay map command.
Inverse ARP is used to map known delcy to the. Okay. This paragraph. मन में पढ़ लो भाई, अपने फटाफट पढ़ लो. पढ़ लिया भाई? फटाफट पढ़ो यार. टेलीकम्युनिकेशन. जो सर्विस प्रोवाइड कर रहा है इस टेलको.
फ्रेम रिले अभी भी चलती है, नई टेक्नोलॉजी
चलती है. LMI के बारे में पढ़ो, फिर डिस्कस करते हैं. ये बात वही थी जो मैंने अभी आपको बताई थी, जो अभी आपने पढ़ी है. That how traffic is transferred. Again, I can repeat if you want. This is R1. Yes.
Locally significant का मतलब क्या है?
यार लोकली सिग्निफिकेंट का मतलब उसने कहा कि R1 के लिए डेल्सी लोकली सिग्निफिकेंट है. यार मैं तेरे को क्या कह रहा था, ये बात मैं कहना चाहता था, यहाँ तू सेम डेल्सी नहीं यूज कर सकता. इट इज नॉट पॉसिबल. हाँ, वो स्विच नहीं कर पाएगा वरना ट्रैफिक को कभी भी.
So तो मैपिंग आईपी एड्रेस से शुरू कर रहा है ना, तो
यार ये बंदा मैपिंग कैसे करेगा? आप वो इस वजह से बोल रहा है क्योंकि वो इसका भी क्राइटेरिया बीच में नहीं रख रहा, वो ये नहीं सोच रहा कि इस बंदे को ही फर्क पड़ रहा है या नहीं पड़ रहा। आप मैपिंग बना ही नहीं पाओगे यार, बना के देख लेना रियल टाइम में। यार खुद सोचना, एक प्रोवाइडर है, वो दो बंदों को सेम डेल्सी अगर यूज करने देगा तो क्या इशू आएगा, वो स्विच कैसे करेगा उनके ट्रैफिक को। अगर वो 3 बंदों को सेम डेल्सी दे देगा, दे दी, तो जब ट्रैफिक आया, वही मैं सेम एग्जांपल ले रहा हूं, R1 R2 और R3, दिस पर्सन विल नेवर चेक योर IP, ही विल ऑलवेज चेक योर डेल्सी। उसने यही बोला ना, सर्विस प्रोवाइडर विल रिसीव योर ट्रैफिक, वो देखेगा फ्रेम रिले हेडर में किसको, डेल्सी को, ऑन द बेसिस ऑफ डेल्सी ही विल स्विच योर ट्रैफिक। अगर इफ यू यूज ऑन द 3 इंटरफेसेस 102, नाउ यहां से आया, यहां जाना चाहता है, भाई किस तरफ जाना चाहता है, कैसे पता चलेगा।
सर अगर दो जन IP यूज करें सेम, सर वो अगर एक तरफ से आता है तो वो रिटर्न नहीं कर देगा अगर 102 है तो।
यार वही तो प्रॉब्लम है, वही तो मैं इस भाई को समझाना चाहता हूँ 3 का एग्जांपल लेके। लोकली सिग्निफिकेंट का मतलब है कि R1 जाने के लिए सिर्फ क्या देखता है, डेल्सी। द थिंग इज सेइंग लोकली सिग्निफिकेंट इज जस्ट मींस दैट इफ सी on R1 there will be a mapping for R2 and R3, yes or no, and there will be no mapping for R1 on itself, yes or no. So R1 cannot ping itself, R1 cannot ping itself. Whenever a router want to send traffic on a frame relay interface, always it will check IP2. If router is not able to find a IP, router will never able to ping. This thing is clear? यार डेल्सी आपको खरीदनी पड़ेगी, घर जाके दोबारा पढ़ लियो उस चीज को, कल पूछ लियो। रीड अबाउट LMI।
पहला जो लाइन है, LMI is a signaling standard used between your router and the first frame relay switch is connected to. मतलब और भी होते हैं क्या खास में?
सर्विस प्रोवाइडर में एक ही राउटर होगा?
नहीं मतलब अच्छा उसके अंदर का बात हो रहा है।
हाँ, एक मिनट हो गया यार, मैं ही समझाता हूँ। आ गया ना, बस यही कहानी खत्म हो जाती है। This is provider. Your site is connected here. You will be connected to one router. There will be many more routers also. This is connected to site B. This is connected to site 3. What is trying to say? LMI will work between your router and frame relay switch. Actually, frame relay switch is also a router on which IP routing is disabled and frame relay switching is enabled. Fine. Now, try to understand a simple thing. What is the use of LMI? देखो, by default, LMI is used to know your PVC status. किस लिए यूज होता है? PVC status जानने के। देखो, now you have defined that if you want to reach, okay, first of all we will discuss about inverse ARP, how inverse ARP will work. Fine, okay. First thing, frame relay is basically divided into 2 parts. Frame relay interfaces, the interfaces on which you are running frame relay can be divided into 2 parts. One is point to point, other one is point to multi. On point to point interfaces, do we need ARP? No. So in the similar way, on point to point frame relay interfaces, there is no need of inverse ARP. Fine, because there is only one other end. There is no need of inverse ARP. But when I talk about frame relay point to multi-point interfaces, there is a need of inverse ARP. This thing is clear? Second thing, let's say R1 want to reach R2. So here I am taking example that del Cs are defined here. To this interface of frame relay switch, we have marked two del C, 102, 103. This is 201, this is 30. First thing, R1 will send a signal to frame relay switch. If inverse ARP is on, and inverse ARP is only on in which case? When you are using which interface? Point to multipoint. R1 will send a signal to frame relay switch. Please tell me the del C associated with my interface. Please tell me the del C is associated with my interface. Now, frame relay switch will tell him that your del Cs are 102 and 103. Now what this guy will do? This guy will put these del Cs in the source and it will generate a frame relay inverse R. Now when it will generate a frame relay inverse R, it will be received by this switch again. Now this switch will check 102 is connected to, because it is having a mapping that when I am receiving something on 102, I have send it out to 201. He will send it out to 201. Bhai sona nahi hai. When it will receive something on, it has to send it out on 103, 301. Now, when R2 will receive the R from R1, it will get to know that I have to use 201 when I have to reach 10001. Yes or no? Okay, how? Because when R1 will send the inverse R, source will be 10001, del C will be 102. It will be received by the provider. Provider will send this ARP to 201. Now ARP is received. Now R2 will get to know that if I want to read 10001, I have to use del C. Now R2 will reply for this inverse ARP. Fine. ARP will inverse ARP reply will be received by provider. What provider will do? Provider will send 2012, 102. Now R1 will check. When he has generated a ARP for the del C 102, who has replied? 100? 100? 2 has replied, yes or no? So he will make an entry in its table that if I want to reach 10002, which del C I have to use? Similar with the case with R3, that if I have to reach 10003, I have to use which del C? Similar is the case with R3, that if it has to reach 10001, which del C it has to use? 30. In this case, inverse ARP, like this inverse ARP will work. This thing is clear. Second thing, this is dynamic mapping. This is dynamic mapping. When dynamic mapping is there, FR network will work like a broadcast network. Will work like a? What do you mean by broadcast network? Broadcast network doesn't mean that if R1 is generating an inverse ARP, it will go throughout the network. It just means that on this frame relay network, if R1 is sending a broadcast, that is allowed. If R1 is sending a broadcast, that is allowed. Let's say R1, this is FRS, this is R2. Fine. This is LAN of R1, this is LAN of R2. This is A, this is B. Now, you have this IP to this IP connectivity, yes or no? And you are running which mapping? Dynamic mapping. Dynamic mapping means mapping is formed by inverse ARP. Mapping is formed by, this thing is clear. Now R1 will send, let's think like we are running RIP between these two routers. I am running RIP version 2. R1 will send a multicast update. So R1 will be able to send multicast update on this particular link, because this link is acting as a broadcast link, not as a non-broadcast link. This thing is clear. I am explaining it again. When I have a dynamic mapping, inverse ARP is on, or you can say when inverse ARP is on and when we have dynamic mapping, NBMA network no more exists. Which network exists? Broadcast. That on these particular links, multicast and broadcast will travel. There will be no issue. But if I am configuring static mapping, static mapping, what you can do? It is your wish. You want to enable broadcast or you want to disable broadcast. And by default, broadcasts are always disabled.
So dynamic mapping में मैं routing protocol use कर सकता हूँ.
डायनेमिक मैपिंग में आप राउटिंग आप स्टैटिक में भी कर सकते हो, पर वे कुछ और होगा. फाइन, दिस थिंग इज क्लियर. हाँ जी,
जैसे वो डायग्राम है, जैसे ये डायग्राम है, ये मैपिंग हुई है मेरी इनवर्स आपकी. अगर ये आईपी एड्रेस बाय डिफॉल्ट कभी चेंज हो जाता है, किसी का कोई कर देता है, तो ये मैपिंग डिस्कनेक्ट हो जाएगी ना.
आपको क्लियर करनी पड़ेगी मैन्युअली. यू हैव टू क्लियर दिस मैपिंग मैन्युअली. फाइन. Otherwise, the LMI working between R1 and frame relay switch will always check that this mapping is fine or not. Fine. Now guys, there are three states for the PVC. One is everything is up and routers can exchange. One is okay. R1 this is, FRS this is R2. You will find inactive state only when from R1 perspective all things are fine, but there is some problem. You will find deleted state when there is some mapping problem. Fine. So that's all for frame relay. Just the basic parts. Fine. Next thing. How many types of FR topology exist? They are basically of two types. One is second is, what do you mean by partial mesh and what do you mean by full mesh? Partial mesh means this is FRS, this is R2, this is R3. See here, R1 is connected to R2, R2 is connected to R1 is connected to R3 is connected to. This particular topology is called partial mesh. And in full mesh, R2 will be connected to R3 will be connected to. This thing is clear? The difference between full mesh and, you can leave these things. See, नहीं यार. Yes, partial mesh is also called hub and spoke. What do we call partial mesh? Hub and spoke. ये नहीं पढ़ना है आपको, ये तीन चीजें नहीं पढ़नी है आपको, छोड़ सकते हो आप इसको. एंड ये पढ़ेंगे हम कल, पढ़ेंगे यार, प्रैक्टिकल कल करेंगे इसका. ठीक है जी, कोई प्रॉब्लम हो तो कल देखेंगे इसको.